Hello, everybody. Welcome to the live stream today. Now, before I even introduce introduce Rodrigo, and we'll get into the content. First thing I want to know is, can you see and hear us? Give us a thumbs up or a thumbs down in the chat there. We're watching the chat as well, and that way we can just kind of get a beat on that. And by the way, at any point in Crowdcast here, I see a yes from Bill Gray. Thank you so much. And Ms. Buzz says yes, and I see Glauber with a couple. Awesome.
Awesome.
If at any point, by the way, if your display becomes a little blurry or anything, sometimes it happens in Crowdcast, just go ahead and refresh your browser tab. That usually clears it up. Super loud and clear. Thank you, Pete. Great. Excellent. So you can hear and see us. It's wonderful. I am David Jones-Gilardi. I'm a developer relations engineer, and I am joined today by Rodrigo Nader, who is one of the founders of Langflow. Hello there, Rodrigo.
Hello, David. Hi, everyone. Pleasure to be here.
So we're going to get some knowledge dropped on us from Rodrigo today. You know, if you take a look at the title of our live stream, it's Beyond Basic RAG, right? So we're going to get into some more advanced techniques, things that you can apply to your RAG pipelines well, I'm not going to give that part away. I'm going to let Rodrigo talk about that. But before we do that, one thing we should probably do is just briefly give a primer on what is RAG, right? So when we're talking RAG, we mean Retrieval Augmented Generation. And if we break down that acronym a little bit, what are we doing, right? Like, so if you think about, if you go into ChatGPT, matter of fact, show of hands in here, I think I know the answer, but I always like to ask this question. How many of you who have actually used ChatGPT or Anthropic or Mistral or whatever to just have a conversation, right? And, if you just say, ask an open-ended question, things like, when did I start coding or something, chances are the LLM is going to come back and it's going to be like, I don't know, who are you? Right. So what's missing there is context. So the large language models are trained on this huge corpus of knowledge, right? But they may not know something about our personal domain or our business domain or something like that. So RAG is a way that you can retrieve domain specific context. You can then augment the knowledge of an LLM, and then you can change its generation, right? It's a way that you can essentially take data that would be your domain data, and you can have the LLM modify its knowledge in real time, right? And by the way, I see lots of thumbs up to that. So it sounds like folks have done this. So, it's a super basic primer. So usually RAG kind of entails both getting data into a vector store, whether it's batch or whether it's real time in your app, and you're going to take some data in, you're going to store that data in a vector store, and usually a vectorized format that then you can use later to ask questions real time. And then you're going to send data over to an LLM. And that way, people use these for like support chatbots, for example, right? It's really important that if you have a support bot out there, that it is actually giving answers that are relevant, like to your particular domain knowledge, things like that. So anyway, I just wanted to set the stage a little bit with what basic RAG is. And thank you, Kampala. I see the perfect audio. I'm glad that sounds awesome to you. And with that, Rodrigo, should we get into some content? Should we bring the knowledge?
Absolutely. Yeah, David, very well described. I think that to start the conversation, it would be interesting to dive a little bit deeper on why RAG at all, right? So yeah, if you just said, okay, Retrieval Augmented Generation, right? And you said it usually involves a vector store. So let me ask you this. Why do you use a vector store at all?
Yeah, well, I mean, me personally, I use vector stores usually in the cases where I do have let's say I have a bunch of documents, right? Yep. That maybe aren't available out on the internet. Maybe I don't want them to be, right? Maybe this is, kind of like sensitive information. I'm in the medical industry, I'm in fintech, something like that. And there's token limits. And even though, I've gotten this question, and I'm glad you asked this, Rodrigo. Yes. I've heard this a lot. People are like the token limits now for some of these LLMs are getting huge. Exactly. Do I even need RAG or whatever? But here's the deal. Imagine for a moment, even if token limits were infinite, and you could just take 1,000 documents and just shove them into the LLM and say, go. Well, the challenge there is that, well, now you've just given it this massive information, but you're not giving it anything that is contextually relevant to the question being asked, right? So and not only that, it costs you money. So when in my personal uses, like when I'm developing apps and that kind of deal, I'm usually using RAG in cases where I have a corpus of knowledge and I only want to pull back the most relevant information to then augment my LLM. So one, it's more efficient, it costs less, and then I can leverage the database to do kind of what it's good at.
Very good, very good. So, but let me take one more step back. Why a vector store? Because if you say I can have,
Ah, yes,
well, I have a lot of data, right? We always had databases, okay? We
yes,
always had ways to store a lot of data and
yeah,
retrieve a lot of data, and there are multiple ways that you can retrieve that data. And vector stores came to the equation because you can retrieve data by semantic meaning, right? You can
right,
find the meaning behind the text. And when did that happen? That happened when language models became good enough to understand the meaning behind text, right? Because otherwise, you're retrieving data in the same way that you will do with hard filters for a database, right? You can actually do that for a RAG system. You can actually hard filter a database and say, well, I want text that is part of this and that part because of some conditions, but that may not respect what you really want most of the times, which is
right.
the semantic similarity. Does that make sense?
Yes, yes, absolutely. I'm glad you brought that up because I didn't mention the similarity part, which is kind of a key factor of a RAG database.
We use RAG, so I think you're absolutely right, right? We use RAG because we have a lot of data that we want to retrieve, and we want to make sure that we're going to retrieve data based on some sort of semantic metric. Okay, we want to ask a question, for example, and we want to retrieve chunks of that database that have parts that relate to what we're asking, right? And
Yes,
how do we assign that relatedness or that relevance? Typically is by using similarity, right? And in one of the articles that I'm writing right now, and by the way, I'm writing a couple of articles on this new article series called Similarity on sorry, Beyond Basic RAG, which the first one is similarity versus relevance, right? And just for as a note here, I'm not the expert at all in all RAG techniques. These folks, for everyone to know, these folks they call me to a live stream and they say, okay,
oh,
let's talk about it. Yeah, but anyway, you can get into a lot of different ways to retrieve and get much more advanced than just similarity. So just recapping, RAG, you wanna answer questions, you want to use textual data, for example, and you want to retrieve that textual data based on semantic similarity. You use a vector store because a vector store is a cheap and efficient way to store vectors, which are embeddings, right? Which are the representation, the semantic representation of text. Okay, and how do you compute those vectors is by using a language model, or even like there are even cheaper ways to compute vectors, right, than
yeah,
language models. Before in the past, we used to do a lot of TF, IDF, for example, and or just embedding models that weren't even like close to the language models we have today. They were much simpler and
oh yeah.
cheaper. So yeah.
Yeah, for sure. By the way, just a couple things. I didn't mention this in the beginning. I just got so excited to start talking with Rodrigo, I forgot. So if you want to ask a question or something like that, you should notice in Crowdcast, usually on the right-hand side, if you're on like a desktop or something like that, you have a little toolbar over there. There's a Q&A section. So if you wouldn't mind, put your questions in the Q&A. That way, other attendees, hello everybody, can then vote those up, right? And it not only that, it gives us a really nice interface when we go to answer those, and it helps with tracking. So please go ahead and put any questions that you might have over in the Q&A. And then the last thing I'll say, I mentioned earlier, Rodrigo, that you're the co-founder of Langflow, but we didn't actually mention what Langflow is. For those of you who are not familiar, Langflow is a tool that you can use to visually build out Gen AI workflows. So any of you guys here have worked on LangChain, right, where you're coding in Python and something like that, you're working directly with the Langflow or LangChain libraries. Now envision that instead of having to work directly in code, you can, in a no-code, low-code way, you can actually stitch together your Gen AI workflows. It's totally model agnostic, things like that. And they're built, it's used for a lot of RAG pipelines and things like that. So anyway, I wanted to point that out before we jumped into Rodrigo's content. So Rodrigo, do you want to jump over to the first blog post and start going through some of the
Yeah,
details?
absolutely. I think we can use the post itself to find some bullet points and start discussing about them. What you think?
We see your screen. Oh, there we go.
Can you see that?
We see all your tabs, man. Yeah. Yes,
Okay,
we see it.
so all right, that's awesome. Okay, so this is basically like the first like attempt to talk a little bit about this difference between similarity and relevance. And I don't think I'm not saying they are exactly different from each other. What I'm saying is that a lot of times we use similarity as a proxy for relevance, but this is not always true, right? What we want when we ask a question to a model is I'm saying, hey, so I'm reading the Harry Potter book, right? And I ask, who's Harry, right? What I want to know is the answer to that question. I want to find chunks or parts of texts within the book, right? That have that contains the answer of this question. That doesn't necessarily mean that I'm looking for parts of text that are similar to this question over here. Okay, but what does that like? Give me an example that where it really like makes sense, right? And I have this one over here, and we can go up again. But this is, I think, one of the best examples. I have a story where Bob invited Alice to go out because he was feeling lonely, right? And the question is, why did Bob invite Alice to go out? If the answer was Bob invited Alice to go out for coffee because blah blah blah, that would be a very good chunk to take, and similarity would have worked very very well, right? But let's suppose I
Right.
have a part of the text where I have something like he was feeling lonely, which led him to pick up the phone, right? Which says nothing about Bob, says nothing about Alice, and says nothing about to go out. But here
Right.
is the reason, right? This may be the reason for why Bob invited Alice to go out. He was feeling lonely, which led him to pick up the phone and blah, and then you assume that because you have a lot of information on, well, you pick up the phone, why? To call someone. He probably called Alice, so here's your answer. It's because he was feeling lonely, right? So that is sort of, and let me try to increase the size a little bit
There
over
you go.
here. That is
Yeah,
sort of
that's
the
very
idea
readable.
behind it. Does that make sense?
Yeah, absolutely. I mean, and you kind of hit on something interesting there, if you mind keeping on that
Yeah,
paragraph, which is like, as a human who, we've all learned how to read at this point, right?
yeah,
We have context clues, right? We can figure that out intuitively, what was
exactly.
going on here. But the LLMs don't know that, right? They don't have that information, right? So that's something that
Well,
we have to
even
provide to them.
I would even provoke that some LLMs already have that, right? And LLMs would be able to do this by themselves. But
Okay?
vector similarity, definitely don't have that,
Right.
right?
Okay.
So when you take the vector of this guy over here, it's going to include the vector of words like Bob, Alice, invite, and go out, right? Which does not correlate at all with he was feeling lonely. Okay.
Right. Right.
And then you have like all of these little examples where you're gonna try to understand what like why and how vectors are represented and why similarity works in some cases, but it doesn't really work in other cases, and it really depends on your type and style of content, right? The corpus that you're using, and you have a lot of alternatives and ways that you can mitigate that problem, David, as we already talked about a couple times. So one of the ways to mitigate that problem is, let's suppose that before getting vectorizing this thing, I am parsing this out, right? Maybe
Hmm.
I'm breaking it down into subqueries. That's one way to do it. Another way is I could process this, right? I could remove words that are not relevant over here, or I could do even more advanced stuff with NLP, like not advanced, but I mean more like go even further with NLP, doing stuff, applying stuff like co-reference resolution, right? Here I have he was feeling lonely. Let's suppose that I had applied previously a system for co-reference resolution over here, where he was mapped to Bob in a previous sentence, right? I was going to be able to see that Bob was feeling lonely. Okay, so
Mm.
these kinds of techniques that are not necessarily built for RAG can help a lot, especially if you use it to pre-process the content that you have in general. Does that make sense?
Yeah, so let's you have some examples here. I see subquery generation, entity recognition, and co-reference resolution. You were just talking about co-reference resolution. Can you kind of go through each of these real quick and,
Yeah, absolutely.
Give an example.
Yeah, absolutely, absolutely. So when you take over here, I'm still trying to think of how can I improve the similarity score or improve the similarity strategy, okay, without replacing it just yet, for
Okay.
it to be a better proxy for relevance. So these are like sub strategies that we can work out, even keeping similarity as a model, right? But
Okay.
what you can take over here is number one, subquery generation. Okay, so imagine you're going to take that one query and uh, to increase the recall or the number, a little bit the randomness as well on the types of chunks that you're going to retrieve to the model, maybe you want to generate subqueries, right? So instead of saying just like affordable smartphones with good cameras, you're saying budget smartphones or budget technology, blah, 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 right? Because we're going to have like synonyms and other different ways to say the same thing that may increase the chance that you're going to find more chunks where the actual sentence or the actual response to your question is. And if you think about that, it's actually sort of a way that you can work out depending on how much recall versus precision you want. And since models today accept a very big context, I
Hmm.
tend to work more with throwing biasing towards recall, right? Let me throw more information to my model, right? And let me try to find add a little bit of randomness to see if I can catch other parts that just my basic semantic comparison wouldn't maybe do. Okay, so this is one type of technique. The other one over
Okay.
here, like two other examples I'm showing. These are just examples, right? But imagine entity recognition. You have text like with a lot of entities. And when you say NER, right? For those who don't know what named entity recognition is basically extracting entities from text. So you have person, money, like dates, author, you
Mm.
have places, locations, right? Extracting entities from the text as a whole. So if you apply this kind of extraction to your text before a form of similarity recognition or retrieval, right? What you're gonna have is more metadata to be used. So J.K. Rowling, for example, could become author, right, in a form of metadata, which would much better match in similarity. Look for famous authors in my chapter, right? So if I look for famous authors, J.K. Rowling is the name of an author, and maybe it's very correlated with author because she's very famous. But if you're just looking for authors in general, there might be a lot of names that will correlate zero in terms of similarity with your
Yeah.
query, which is find me authors. Does that make sense?
Yeah. That's actually a really neat point. I'm going to put you on the spot here, Rodrigo. So feel free to have fun with this. But that's actually, I find that to be really interesting because if we're talking about, when I'm thinking about relevance, right? Like in given the example that you have here, and if
Yeah.
I've got a RAG pipeline and I want to ensure my data is more relevant, meaning the data that I'm returning out of my vector store or something like that is
Mhm.
essentially more narrowly focused on whatever it is that I'm trying to answer. I would feel as
Okay.
though that I would want to be more specific and use something like JK Rowling. But what I think I'm hearing, well, I guess it depends on what you're intending the outcome to be here.
Yeah, I think it depends on the use case, right? The problem is when you look for something like find me authors, right?
Okay.
And let's say you take the word authors, and let me draw in the screen in a very poor way over here. Let me do something very ugly. So let's say you took the word authors, right? Can you see my drawing, by the way?
Yes, I see your so far pretty okay drawing.
Okay. All right. So let's say that you converted authors into a vector, right? A vector
Okay.
of numbers. This is the embedding for the word
Okay.
authors, right?
Okay.
The word authors is probably maybe more similar to the word like books and to the word text and
Yeah.
articles and papers. I don't know,
Then J.K.
much
Rowling.
more
Yeah.
than J.K. Rowling, right?
Right.
So
Right.
it's very likely that your first, like your top rank candidates are going to be stuff that you don't even care about, right? And you're
Hmm.
gonna have a ranking of. So when you're doing RAG, what's happening is that you are first. So first you're retrieving and ranking, right? And then you have a rank, like a list of candidates that you're gonna say, well, give me just the, I don't know, the 10 first candidates, and I'm gonna feed those candidates into a language model, right? As context.
Oh,
So
so you're doing
yeah,
you're almost doing like a pre-processing entity
exactly,
recognition step here. That
exactly, exactly.
okay, I got you, I got you, I got you. Okay. So by the way, this ties in. By the way, your drawing was great. I thought your drawing made a ton of sense. So keep doing it. So there's a couple questions here that I
Yep.
think are relevant to what we were just talking about. One here from
Mhm.
Jo said, if we go back a little bit, I thought affordable smartphones and budget smartphones were supposed to be
Okay.
close in vector space, right? But what I
Yeah,
think I
I agree.
just got from what you explained, it's it's not. Yes, they are. I would argue that they are probably somewhat close in vector space.
Yes.
But this is being done. I'm gonna state this, and you can tell me if I'm wrong. But I believe what
Okay.
you're saying is you would do this as a pre-processing step, just like what you explained, right?
Exactly. I would do that as a pre-processing step. Oh, actually, so this is different, right? On the entity
Okay.
recognition, I'm talking about, and that's maybe poor explanations here because I agree with you. Oh, on the entity recognition, I would do a pre-processing step to the article itself, right? So you're taking your chunks and you're pre-processing these chunks, either changing, literally changing the words over there, right? Or adding metadata to those chunks. Or in the subquery generation, what you're doing is you're pre-processing the query, right? Which is different as well. Okay.
Mm,
So you can do pre-processing one to the query or to your chunks. It's obviously easier and much cheaper if you just need to do pre-processing to the query. So whenever that's possible, that's that should be the first tentative approach. Does that make sense?
got you. Okay, it does. It does. And then I also see a question here from Patrick. Hi, Patrick. Saying with the entity recognition, is this using entity extraction with something like Neo4j or just model inference? Like, how are you doing the
Uh,
extraction?
okay. Yeah. So for entity recognition, there are a couple of techniques, right? This is typically what people use on entity recognition are pre-trained models specific for NER, right? So basically, what you're gonna have is and I'll explain why this is not redundant because it may sound redundant because we are avoiding to use a model doing similarity, and then we are going back and using a model for NER. But the thing is that an NER model and typically task specific models like an NER are much, much, much cheaper and much
Right.
easier to run, right? So what you can do is you can typically use libraries such as Spacey, for example. I had it open over here. So Spacey is this great NLP library for doing all sorts of pre-processing in text, anything related
Oh,
to NLP, right? So you can think from tagging the text to extracting the entities to lemmatizing, even like lemmatizing or extracting, normalizing the text, like taking verbs and putting all of them in the infinitive form, whatever, right? You do all sorts of pre-processing. There are other libraries as well, like NLTK and so on, that you can use, but you can do a lot of stuff and pre-process either queries or chunks so that they become more suitable to the task in hand, if that makes sense.
okay, okay. So you would let me
Yep.
throw this back at you to see if I've got it right. So
Yep.
what you're suggesting in a case in a pre-processing step, instead of using one of the large language models, right, is you use one of these smaller, more narrowly focused like pre-processing models in this example potentially, if this is what
Mhm.
you're trying to do, and that is what you're actually using, which is faster, more efficient, things like that. It's not going to cost you as much and that kind of deal to do that pre-processing step and then taking the result of that, of course, along with
Yes.
your prompt and everything, and that's what you're feeding into the LLM.
Yes, and remember that whatever you're doing to your corpus, as long as your corpus is just being run, like it's not dynamic, right? It's not updating every day. You're doing that offline. So you just applying that once. So whatever system you want to do there, pre-process, change everything in your text, normalize it, change words, add metadata, extract more data. Everything that you're doing offline before retrieval actually happens, right? You're just preparing your database to become richer, right? So that the models that are going to look at that and look for a similarity or a comparison or whatever have better information to feed the retrieval system, if that makes sense. And over
Okay.
here, that would be an example, right? Author could be a metadata. Let's suppose you have an extra column in your chunk data. You have the main textual part, right? You may have the index name. You may have like a couple of other, like date where that was extracted, maybe the source, and so on. And maybe you have something more like contains entities like author, contains entities like I don't know, contains monetary values, contain company names or something like that. Because then you can much in an easier way, one, filter, and second, find different ways to apply similarity to increase the similarity score over there for those guys.
Okay. Okay. Cool.
Okay.
Now, I see this really, really poignant question here from Sarab. So
Yeah.
let's see here. This one is how do we know what kind of pre-processing we should apply, since we would never know what the user could ask? In the example you showed around a user asking famous authors here, it made sense to convert J.K. Rowling to author, but in some other question, this might be worse for us.
Okay, I'm gonna have to disagree with that, with the part that you say we never know what the user should ask. I think this is completely misleading, because depending on the type of application, you definitely know what the
Yeah.
user typically
Yeah.
wants, right?
You have
If
a
you're
good range. Yeah, you'd have some idea.
yes.
Yeah.
So if you're building a general purpose like Agent Jarvis thing, yes. So you're probably right. You caught me, and then there's a lot to think about. But still, right? Even if you're doing something like that, more information and more metadata is always useful, right? You don't necessarily need to apply it with hard code, but you can use it to help in the similarity. Let's say that you're vectorizing the metadata as well, and instead of retrieving just the similarity between the chunk, you're using some of the other fields as vectors as well, right? And you are applying similarity to that. I just think that the basic and vanilla similarity is just one way that people found that works, and it doesn't represent reality, right? It's one quick way, easy way to get close to what people expected. It worked, and it sort of became the standard for the community, right? But more like there is much more than just vectorizing the text content, the text chunk, if that makes sense.
Okay. Okay. And then I see actually one more question for you, and then we'll move on. And then one I can answer real quick from Martin here. He said, so just to understand, you're talking about the processing of actual content, but how important is pre-chunking, cleaning, and optimizing of the content? In my personal opinion, the cleaning and optimizing thing is actually super important. I feel like when we're talking about these kind of applications, the whole garbage in, garbage out absolutely applies.
Yeah.
Right.
Yes.
So that I don't think anything we're talking about here changes that. Right.
Yeah, absolutely. And that's true for in multiple dimensions, right? One of the ways that I can think about cleaning is, well, you have a lot of content. Get rid of duplicates. Get rid of repetitive or very, very, very similar content. Why? Because it's going to be one more candidate that is repeated in your rank, right? So you're going to get more information of the same to the context, which is not very useful.
That's a very good point.
You're okay. And then second, how can you get rid of really unnecessary information? Textual content usually contains a lot of junk, and that's not only related to the context of the text, it's also the kind of information that you have there. For example, you have a lot of HTML tags. You may have real junk over there that you can clean and clear with these libraries, these NLP libraries, which is super useful, right?
Yeah.
So let's say you get rid of like stuff like preambles as well. You get rid of conclusions in text. There is something similar in the retrieval weighting. You just want to keep the meat of articles, and there you go. Like you can start being very, very creative. There are libraries for parsing text like this. I remember one for PDF called Growbit. We used to play. We can throw it after that. The spacey Hugging Face models for some of this stuff. But yeah, so a lot of techniques for cleaning, improving your information before it's vectorized. And remember,
Yeah.
when you remove more information, you're spending less as well, because
Yep.
your vector, like your vector model, the embedding model, spends money, right? Or at least most of them, right? Some are cheap, some are almost free. But in general, you're saving money, you are being more efficient. And well, what are you really doing is you're spending more time on the pre-processing. But in my experience, at least, it makes you learn so much about the data that it tends to pay out, right? That's
Right.
how
I hear you.
I put it.
Yeah,
Yeah.
and a quick anecdote on that, by the way. Talking about the data cleanup and such. I had an application that I built that had a bunch of various items. Both living and non-living items, and that kind of deal with descriptions. And funny enough, when I generated all of the descriptions for these items, they all started with the same sentence structure, right? So they all started
Yeah.
with a something something, and then it describes the thing. Well, come to find out, when you embed that, right, you're embedding,
Yeah.
semantic information, and that's part of the semantic information. And so what happened is that pattern started to express itself in my results. And I was
Yeah.
wondering why sometimes I was getting some odd hits on things. I'm like, why is this thing here showing? Why when I was looking for like a cup of coffee did a tiger show up? Right.
Yeah.
And
Yeah.
it
Makes sense.
turns out that the sentence structure mattered, and that when I got rid of the homogeneous sentence structure across the board, all of a sudden my results were wonderful. Like it was amazing how that mattered, right?
Yeah,
So
the stop words typically are
yes,
very noisy, right? And
yes,
they say, well, we're in times of LLMs and so on. Don't care too much about this. I agree that you shouldn't be like desperate about removing stop words, normalizing the text. But I think the lack of paying attention to that kind of thing is also a problem. And you see a lot
yes.
of applications where things don't work properly, and it's very clear that the problem would be easily solved by some rule-based processing applied to the database before retrieval, right?
Yes, absolutely. Okay, good. I think let's go ahead and move on, and make
Okay.
sure we're getting through all the content. There's a lot of great questions that are in the QA, and I see your question there, Mohammed, about graph rag and rag. We'll get to that later, or put it in the QA, please, so we can hit on that one. All right,
Okay,
go ahead,
so
Rodrigo. Yeah, let's see where we go
do we
next.
go with? Okay, so this is the second one, everyone. So this is, and this week I plan to write, maybe not this week, but I'm working on two others, right? We did one on similarity versus relevance. That's the first one. Oh, and by the way, I didn't mention that, but when we get, we talked about like ways to mitigate the problem with similarity, but there
Mm,
is something else, right? Which is what can I use instead of similarity, right? So
mm.
when you're thinking about similarity today, you have a query over here, right? Let me do something. You see my drawing again?
Yes.
So you have a query, right? And you have a lot of chunks that are vectorized. All right. Okay.
Okay.
These chunks and the query were vectorized with the same model. And what's happening is that your query is being compared with each one of these chunks.
Right.
Okay. And that's where the similarity is being applied. So we're basically taking the similarity between your query and each one of the chunks in the entire article and ranking the most similar ones. Okay, cool.
Right.
So what if we say I don't want to use similarity at all because there might be a better way? What would be a better way, right? I think a better way would be, what if I could train a model to extract relevant answers to my question. Okay.
Mm.
So in the end, remember, we are using similarity as a proxy for relevance, but what we actually want is relevance,
Interesting.
right? So you can train a model. Let's say you train a deep learning model or you train a machine learning model. What, like there are a couple of pre-trained ones that you can use, so that you're going to give the sentence, right? And instead of having these vectorized and looking for similarities, what this is going to do is it's going to look at the entire corpus and find a chunk for you, right? So let's say a model would say, well, from here to here, right? It's going to give you already the output, right?
Hmm.
Which is the in air quotes most relevant part, okay, or most relevant parts. Okay, this would be a model trained specifically for relevance recognition. Okay, and especially useful in cases where in these cases where similarity is not necessarily the best, like the case of the authors or with Bob, right, where you have answers that don't look very much like the questions, or that don't contain the questions within them, right? Because you can have all sorts of like textual ways that you're gonna answer a question, who was Bob living with, and the answer could be Bob was living with. That's one kind of article, but you could also have much more subjective and articles that propose information that won't be in the question, right? So depending on the use case. And I think that this will become, to be honest, I think this will become standard at some point, right? I think this will replace similarity at some point. Models like Colbert, Flair. If you want to take a look, it's in the article. Take a look at
Hmm.
that. At those, I
Yeah.
linked the papers to them, and or even training custom retrieval models. This is slightly more advanced, but I think that's the mindset, right? To think one way, like a way beyond the basic and vanilla rack. Okay, so moving to retrieval weighting, if that's the goal.
Yeah, let's do it.
Okay, so retrieval weighting. The idea on this article over here is basically thinking about ways that you can reduce the overall noise in your retrieval. We just said that we have the chunks vectorized, right? And we have metadata as well.
Right.
And let's say I want to ask a question that where the answer should probably be before 2021, right? Or in the year of the pandemics, okay, 2020 to 2021, something like that. Then what you can do with metadata filtering in the typical standard way of filtering is hard filters, right? What you're
Okay.
what you're gonna do is, sorry, let me find some better part of the article. So what you typically do with the metadata filter is you're gonna say like a hybrid filters like we have in the databases today. You're gonna do, okay, I want text that is similar to my query, but that apply to these conditions. And conditions could be the date before 2021 or something else, right? Or the tags contains these tags. Okay. All right, cool. This is hard filtering, typical standard stuff. But let's say that there's a higher probability that my content is on 2021, and I don't want to be so like like dogmatic with that information. I want to let the model decide instead. So what you can do is you can create weights out of these conditions, out of these fields in your metadata, and apply these weights to the score that the similarity is going to give you. So you're
Hmm.
gonna you're gonna apply your similarity stuff. You have a list of similar chunks, right? And there, let's say we have a score from 0 to 100 over here, right? So this guy is 75, this guy is 73. Okay, this is how basic RAG works. We're gonna have scores for each one of them. And let's say that I have another factor now, which is, for example, the recency of data. Okay, so
Right. Right.
I'm gonna weight more recent chunks with a slightly higher, like I'm gonna apply some weight to that in a way that it's going to stand out, right? So
Okay.
for stuff that is very old, let's say this guy over here is very new and this one is very old. Okay, so this is 2020, I don't know, 2010. Okay, and thus it's going to be applied with a score of, let's say, 0.2. This one is going to be applied with 0.8. I'm sorry about this. Oops.
You can't just move
Oops,
it
I
all
don't know how to move.
over.
Yeah. Oh, that's terrible. All right. All right.
It's
It's a
okay.
good
We can see
tool.
it.
So in any way, it will end up that in the final table, in the final ranking, this guy over here is going to pass that one, and it's going to
Mm,
be the first in the retrieval list. And when you apply weights to all of them, you're going to see a completely different list of chunks retrieved to feed your context, right? And that's based on a specific rule that you applied. And in this case, I'm saying, hey, let's weight the time factor. Okay, so time-based weighting. Where this is useful.
gotcha.
This is super useful, by the way, right? So
Yeah,
time-based weighting
yeah.
is very, very useful. So you're working with financial data, especially. You're working with stuff that is time sensitive and so on. You need for information to be recent, but you also don't want to say, hey, just grab me information from yesterday. Maybe
Right.
you want to apply a higher weight for stuff that came yesterday and a lower weight. Sorry, the opposite, right? So you want to
I
weight a little bit. You get the point. Yeah.
Oh yeah, no, I could see totally applying that. I mean, as a developer myself, and I'm wondering how many of you have run into this. Like, the I don't know how many times others here have come across this. Like, I'll ask, maybe I'm talking to ChatGPT or Copilot or something, and I think
Yep.
actually Copilot is a great code companion. I use it all the time. But one thing that they are actually terrible at is giving the right versions and or dates of packages you might be asking about. And it's like I can't tell you how many times I'm like, hey, let's talk about this package. It might do this. And it's like, oh, yeah, use version 0 dot whatever. And then you look and it's like, oh, that's a year old. Thanks. That
Yeah.
feels like this might be a neat case for something like that, where you want to ensure that you're getting the very latest data on that. And you might kind of just time out, or, kind of like, as you're saying, like apply a heavier weight to those things that are newer in that
Yes.
particular use case. Right.
Yeah, and how does it happen? Like in practice, how do you apply this? Is
Yes.
exactly before feeding the context, right? Because you did the retrieval already, you extracted the
Ah,
information, you already have a ranking with, let's say, your top 100 candidates, right?
got
Now
you.
you can re-rank it, right? It's a form of re-ranking, right? Based
I
on
got you.
these weights. And now I just gave the example of time-based weighting, but let's think of other ways that you can weight your data. You could weight your data based on the source. Okay, I have New York Times information. I trust that journal, but there are a lot of other journals I have that I trust a little bit less. For example, right? I don't want to exclude them because they may have relevant information. So what I can do is I can apply weights, and I can do that even manually, right? There are multiple ways that you can synthesize weights in an automated like manner, but you can also apply weights manually depending on the size of difference in your metadata. But let's say you applied a higher weight for stuff like for journals or papers that you trust more. A good thing I like to think of weights, a way that I think where weights are going to be very, very useful is when you think of research papers. And we know that one clear, a good factor to use for better versus worse papers is the number of peer reviews, right?
Okay,
So if a
that's fair.
paper has more peer reviews, I can weight it a little bit higher, right? And weight less
Yeah.
papers that are not reviewed at all, right? So imagine you do a linear approach where papers are better, like are going to be used with more assertance. Is that a word? Sorry, bad English here. So with more confidence,
Yeah.
right?
Yeah.
And we're going to decrease the weight for those papers without a lot of peer reviewers, right?
Got
Another
it.
another. So you can think of journal. You can think of even the source, the website, the size of the website, okay, or the depth of the content, depending on like how many pages a web scraper had to look into to find that versus it found on the first page of a
So
website.
that's
I don't
something
know.
you could
You
then,
can
if
be
you want to
so
apply
creative.
this kind of technique, then it seems like that you're saying you want to do this before the context step. So what I'm
Exactly.
hearing then is you could, as you are pre-processing data, but in your metadata, right? Like when you're pulling that data back, you could be looking for, hey, what's the date, or how many pages,
Yeah,
or how many peer
exactly.
reviews, and just return that back. And then it sounds like, I mean, correct me if I'm wrong, but it sounds like it's a pretty simple calculation then, as
Very
long as
simple.
you
It's
know
a
what
matter
those
of
values are. Yeah.
in most cases, it's a matter of taking a metadata that is already there and converting that into weights and normalizing that into
Hmm.
weights. For example, let's say I have data from 2010 to 2024. I have 14
You're gonna make a
years worth
scale.
of data. I
Yeah.
could scale that into 0 to 1, right? So
Got
convert
you.
that into a 0 to 1 weight. And just apply the weight right after the similarity is computed. Okay.
Got you. Got you. By the way, for everybody, if you didn't notice, somebody had asked, I think it was Cedric. Hi, Cedric. Like, I haven't seen Cedric in a while. Hi there, Cedric. If you are looking for the links, like to the blog post that Rodrigo is, talking about and things like that, at the bottom of, Misbah just posted them. Thank you, Misbah. But at the bottom of your Crowdcast there, you should see a little green little thing that right now it's the start of the repo. Before there we go, retrieval waiting. I think he's cycling through them right now. So you should see links that are popping up, but if not, we'll try to be linking, posting the links in the chat as well. All right, sorry to interrupt you, Rodrigo. I want to make sure folks know
No,
that.
that's great. That's great. Yeah. So please do, and feel free to ask any questions as well. These are not supposed to be static articles too. So if you have
Great.
ideas or stuff that you think we should add over here, let's make it better, like together, right? I'm super excited to learn more, and I'm learning and reading some of the papers as I go through this as well. So
Yeah.
I'm super excited to hearing different techniques and so on. So on contextual weighting, we are doing sort of the same thing, but here I'm talking about part, and that correlates a lot with the cleaning part that someone raised up over here, right? This is same thing. Let's say I don't want to keep introductions out of the equation, but I want to weight it very, very uh, low. Okay, so I want to
Right.
deprioritize it. All right.
Right.
Whereas maybe the methodology of a paper could be super weighted, right? And I always want to weight that very high, very hard. Okay, same thing for length normalization. Big problem with RAG is that suppose, so David, imagine this situation. You have a big corpus and a very small document, and both
Mm,
talking about the same thing, right? When I ask a question, chances are that the most most of the chunks to be retrieved are going to come from the big source, right? The
right.
big corpus,
Right.
because
Right.
there is
There's
just
just
more
more of a
information
chance,
over there.
right? There's more information.
Statistically, yeah.
Yes.
So
Yes.
what you can do as well with weights is length normalization, right? You could grab the size of the corpus from which a chunk comes from and do an inverse weighting based on that, so that you can spread out your retrieval chunks a little bit better. Okay,
Right.
especially when little documents matter a lot. Let's suppose you have very small but very specific and good documents, and you have a lot of general big chunks of documents that are from different sources, right? You probably want to add more weights to the small papers, or to, sorry, not papers always, but to the small corpuses, I don't know, and you're gonna use those that as a factor, right, to reduce the bad distribution. That's sort of what TF-IDF does in length normalization. That's called length normalization, and applying
Okay.
that this small reduction factor can be a good way to normalize across like sizes, content sizes. Okay, so that's sort of the idea. I plan to write some of other blogs around text splitting, so techniques, different techniques for text splitting. Another one on agentic RAG, another one on
Cool.
graph RAG, which I really want to dig into, like hierarchical ways of doing RAG, and so on. So
Got you. Okay, so we've covered a bit of similarity, and relevance and retrieval weighting. Are there any other methods, things like hierarchical retrieval or prompt caching? Anything else that you have material here, stuff you want to talk about? I also want to give a little time to answer some of the questions. There's a lot of really good ones in the Q&A, so I cannot
yep.
wait to put you on the spot. But I did want to know, are
Okay.
there any other methods that you wanted to talk about?
Yeah. Okay. I think that so prompt caching is super hot right now. Probably everyone over here knows that Anthropic released a model that does
Mm,
prompt caching, right,
okay.
with Claude. And the idea behind prompt caching, we can spend like an entire hour just talking about the technique. And actually, there are more than like, it's not one technique. The technique I've been digging into comes from a paper. Let me show you so prompt cache. This is not like, it's worth the read, right? The paper goes through prompt cache on attention inside the model itself.
Hmm.
How caching can be used to to uh, re so to recompute, not have to recompute the key pairs inside of the attention model. So the transformer models basically vectorize your text, and then it creates relationships from each token to each other token, right? Creating these relationships takes a lot of time and takes a lot of processing. And what prompt caching is doing is basically saying, hey, I'm just going to compute these relationships once, and I'm going to store those relationships. And then next time you use the same text, I already have these relationships. I don't need to compute that again, and I'm gonna save a lot of money and a lot of time on that. That's a little bit. That's not exactly what Anthropic is doing, but that's the description on this paper over here, which I highly recommend. But the technique as a whole, either with this approach or not, is proven to decrease the price and increase the efficiency by these models, especially with long prompts, by 90%. Right. So that's huge. We can spend like an hour just talking about this. I really think it's something useful to look up into. I think other models are going to catch up, and probably OpenAI and others are going to introduce prompt caching as well in one or another way. Maybe they're not going to even call it prompt caching, right? But the idea is to reuse the vectorization of a part of the prompt, right? Because that takes time. Okay.
Yeah, because right now we're processing it every single time, right? We throw it over to the LLM. Exactly. And I know for me personally, I've had some really chunky prompts that have a lot of this. So I'm paying that cost every single time. Yeah, no, that seems super cool.
And that's from day one when I saw what people started doing, because it worked, right? People gave these huge instructions to models, and models started to respect those very well. Like on times of 3.5, GPT 3.5. And these worked, but from that moment in my head was like, oh my God, but we're reprocessing. And I also didn't know a way of, hey, how is this problem going to be handled, right? And it seems like prompt caching is going to be the solution for that problem. It's becoming super like mainstream and well adopted. So nice to look into. When it comes to other techniques, like I like to think that with RAG especially, I like to think of ways to mimic human behavior, right, David? When you're asked something, let's say I ask you something, right? So Twitter was banned in Brazil, for example. I'm giving you a topic, a hot topic, right? And is the law correct in Brazil to apply that ban? Yes or no? If I ask you that, you're gonna take a law book and start to search, right? And we as humans, we have a lot of information and a lot of we are sort of pre-trained to do this kind of in our own way. Right. And if I ask you, my guess, right, or at least myself, how I would look for that information is I typically try to search for the right book first. Then when I grab that book, I try to search for the right chapter. I don't read any information that does not even seem to be on the right chapter, right? And I think a lot of what we're doing with vanilla RAG is exactly the opposite. We're chunking everything, and we're comparing similarities against everything all the time, right? Which increases a lot the amount of noise that you get, because you're getting a lot of chunks from paragraphs that don't even have to do with the topic, right? So if you think of hierarchical search, is sort of this idea where you're going to classify, categorize, or create a taxonomy around around these chunks. That is a hierarchical categorization, and it could go from corpus to documents to paragraphs or chapters to paragraphs to sentences and so on. And you can make this bigger and bigger and bigger, right? But you can summarize the information in every step and create an average vector for each one of the layers, right? So you're gonna only look at the bottom layer if the summary vector makes sense for you to dig into that. Otherwise, your algorithm won't even go there. Does that make sense?
It absolutely does. I mean, at least as I'm understanding it, so you can use that as a mechanism to significantly reduce on essentially the amount of processing lookup you need to do, right? Because it's almost like it's almost like what I'm thinking about, and I'm going to go to Cassandra, like a Bloom filter, right? You're saying, hey, like I'm going to look at this summary, and that's going to be my condition of whether or not I even look deeper, which can
Yeah,
prevent me from a
yeah.
lot of extra processing if the summary
Noise,
doesn't match up. Yeah,
noise. Yeah, and
yeah,
it's just noise because if you ask a question, especially using similarity, you're gonna find a lot of stuff that is similar, but it's not necessarily relevant, right?
that's
And
great.
how can you check if that's relevant first? Well, maybe not looking at sections that has nothing to do with your subject, right? Does that make sense? So if
Mm,
you have even models or that sort of calls to the agent type RAG, right? So
got
so
you.
agentic RAG, which is the agent could be digging into and checking. Well, do I want to look here or do I want to look there?
Right.
Yes or no? And only inside of that document it's going to be applied the similarity through all everything, right? So that's like different ways that you can apply that, but it could also be applied directly from the RAG if you have summaries or the mean vector, the average vector of sections, right? So that you
Got it.
say, hey, I'm not gonna traverse that part just yet. Graph RAG, right? I'm not gonna go
Right.
that far because it doesn't have enough similarity just yet. Does that make sense?
Absolutely. Yeah, it totally does. And another recent anecdote, and an app we had built for one of our hack nights, actually, it had need to, um, only show relevant results based off of certain vendors, depending on what was submitted. I could totally see a case
Exactly.
where,
Yeah.
in that
Exactly.
case, for the vendor that you pull out, you're checking the summaries. Does this summary even have this vendor in it? Because if it doesn't, there's no worth at all going and looking further into the data, right? Or,
Yeah,
or
and
something along the lines, or whatever.
which entails uh, entity extraction again, right?
Yes, yes,
If you
yes.
have very good
That's
entity
cool.
extraction and you have filters over there, you say, hey, I'm asking something about the company Apple Inc., right?
Right.
This chunk has nothing to do with Apple. There is no metadata saying that it's talking about Apple. So I'm not even looking that chunk. I'm filtering much better. Okay. So
Got
creating
you.
pre-process your data set, pre-process your entire corpus, create better tags for hybrid filtering, apply a little bit more careful cleaning, and maybe if needed, do some sort of hybrid approach. Sorry, a hierarchical RAG retrieval part of the step. I think that's going to promote your RAG from vanilla to super professional, right? That's
Got you.
what sounds to me, right? If I come from an outsider point of view without knowing the problem at all.
Got you. Awesome, Rodrigo. Okay, so we have 2 minutes, and we've got
Okay,
some
go ahead.
fun Q&A questions. We've actually been answering some of those as we go, but this one is the most toply rated
Let me.
question here, which says, here we go. Recently, OpenAI enabled the functionality to fine-tune its main models. I want to know how this functionality can be used in conjunction with RAG to achieve the best possible results. I wonder, do you have an answer for that one?
Okay, so fine tuning, right? Let's talk about fine tuning a little bit. Uh, Basically, what fine tuning is doing is there are two parts of training a model, or maybe now there is more than that with
No.
reinforcement learning. But the
Yeah,
first one, training a big model, is literally the model is just reading. And let me ultra simplify. Experts, please forgive me here, but I'm gonna pretend this is true, right? Imagine the model is just trying to predict the next word. Okay, so you take a machine learning model and use as label the next word in books and books and other books, right? All the model has to do is to try to predict the next word. What it's doing is, in the end, it seems that what machine learning experts found is that predicting the next word is a task hard enough so that the model had to learn so much more to be able to predict that well,
Hmm.
right? That's how these models started to become smarter and smarter and smarter, like GPT-2, for example, right? And GPT-2, and then they said, okay, what if I try to do the same thing, but with more data? And then they said, well, what if I multiply the amount of data by 1,000? I don't know. And they just started throwing more data, bigger models, and they saw a huge increase in the learn curve. And that was like, oh my God, these models are really becoming intelligent, right? And that's sort of where this went. Now, where does fine tuning come to the equation? So the model learns sort of patterns to predict the next word, token, or
All right.
or even not the next one. It's more complex than that, but let's pretend. So what is fine tuning doing, right? Fine tuning is basically saying, so multiple types of fine tuning, right? You can do fine tuning to get your model more familiar with your data. Let's say you have some terminology that the model never saw before. Let's say
Okay.
you have specific data. There is a data about planets that you're researching that has specific names, and your data is super specific. So you're gonna run this model, train this model on that data so that it's trying to predict the next word in that context, right? It's by consequence having to learn patterns that relates to your data, right? So it's not only learning that those new tokens exist, but it's also learning patterns on how they relate to each other. Like
So does this
language is, go ahead.
sorry, so does this mean that for some cases, going to the question, right,
Yeah,
that with a better fine-tuned model, you may be able to reduce some of the need for some of the RAG, like RAG application,
absolutely,
because then you can
absolutely,
leverage more of the model's capabilities if it's been fine-tuned
absolutely.
properly, kind of thing.
Absolutely,
Okay.
absolutely.
Okay.
Yes, 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 yes.
I
I
see.
think so. I don't know. I think the question is, how much is it worth it in terms of uh, how can you do well with just rag before
Okay.
you need to appeal to the fine tuning side
Right.
of things, right? Because the impression I have today is that rag per se achieves, if applied well, achieves so well
Yeah.
that I don't know. I don't know if it's worth it, especially with models. With having, we're in a stage where models are coming, new models are coming every month, right?
Yeah.
And I'm gonna fine tune something. I will want to fine tune again next month, and then there will be another model next month.
And maybe
So
there'll be a threshold you pass, and then all of a
yeah,
sudden this fine-tuned
exactly,
model is doing as well, but we're not quite
exactly.
there yet. Yeah.
I agree. So I think there will never end to exist the need for RAG. I find it very, very hard to believe that. And not talking about just the vanilla RAG, but any type of RAG. When you say feeding database information to the model, right? In one way or the other, either
Yeah.
fine-tuning the model for that, whatever, right? But you need way to select data from database, even if
Yeah.
that's the data to fine tune, right? Because even for
Yep.
fine tune spends money, right? And you may not want to retrain or fine tune your model on everything. Okay, and
Yeah, it's still
just for
cheaper and
that
more
matter,
efficient usually to rely on the vector store to handle RAG and return back
yeah,
relevant results than it is to try to
yeah,
retrain or something like that.
and I think that's going to keep being the standard for a long time
Yeah.
still, right?
Yeah.
I doubt there will be a better way than vector stores for most of the use cases in the next couple of years. So that's how I go about it. Another type of fine tuning you can find out there is a fine tuning for task specific models, right? So let's say I want to perform classification. You have a couple of classes, all right? I need to find, like, you have a text, right? I need to classify that text into an emotion, right? Is the user happy, sad, angry, or whatever? And I just have 5 classes or something like that. Fine tuning models for a specific task is super useful, right? And typically makes you spend less money. And it's not exactly necessarily what OpenAI or other models provide, but if you take open source models, and that's why I love open source models, is because you can do everything with them, right?
Yeah.
If you go to
Yeah.
something like Hugging Face, for example, let me share my screen real quick. Sorry about
Yeah,
that.
go for it.
Yeah. So if you go to Hugging Face, for example, they're gonna have a pool of models of all types, right? Multimodal, computer vision, natural language processing, audio model, tabular data, tabular model,
Oh,
reinforcement
cool.
learning, and so on. Right? So for each one of, like, each one of these are categories, and you have thousands of models, right? And these can be fine-tuned. These can be adjusted to specific tasks. If you are an expert in training, these can be retrained. If you are an expert in machine learning training and like PyTorch and this kind of stuff, these can be merged. You can merge
Right. Right.
models with different abilities, right? Which was actually the initial idea behind Langful. How can I have models connecting to each other and performing better than just a specific task? Of course, today it's much more than that, and we shifted gears a little bit. But the idea that these there is much more than just LLMs per se, and text prediction and
Right.
chat like models is huge.
Right.
And I think there is just a minority of people actually realizing that. For example, today you can literally come with Langflow itself, you can instantiate a Hugging Face model, whatever model you want, right?
Right.
You can instantiate it either locally or with a Langflow server, Hugging Face server, sorry. So the possibilities are very large, and they go beyond what is just the surface of the mainstream providers, right? And we
Right.
know these providers are like on top of the list, and they're still winning. But I'm a truly believer in the open source in general, right? Not only for this, but I think the open source is winning a lot of space and gaining like a number of use cases that 1 year ago they weren't.
Yeah.
So very
No,
excited about
that's
it.
yeah, that is for sure. The amount of progress, the amount of improvement we've seen over the year has been pretty amazing, actually. So we are definitely out of time. We should probably let everybody go so we don't hold on to him too long. But thank you so much, Rodrigo. This was like super informational. I learned a bunch today. So hopefully everybody as well who joined us did today as well. If we didn't get to your questions, sorry about that. We always try to get to as many as possible. With that, Rodrigo, thank you very much. Have a great
Thank you,
rest of your
David.
day. And
Thanks, everyone.
everybody as well, take care. And thank you for
It was a
joining us
pleasure.
today. See y'all.
Thank you. Bye bye.